for the ferrous material. Now when you plot it into log law scale, we will have a three distinct trilinear regions. Okay, one is low cycle, you see 0 to 10 to the power 0 means 1 to 10 to the 3 is low cycle fatigue. Then high cycle start from 10 to the power 3 beyond 10 to the power 6. But from 10 to the power 3 to 10 to the 6 we will have a finite life, and beyond 10 to the power 6 is known as infinite life. And please recall, if there is S dash E is mentioned, this is S dash mean to imply that endless limit of the specimen obtained in the testing. Some people use SBE or STS, it doesn't matter. The fact that E is endurance, E stands for endurance. Instead of some literature will say SB, subscript B for bending. Okay, that is tested B, but nowadays if you see MMPDS and all, they are generated through Excel loading only. So yeah, that brings out to two definitions. One is low cycle fatigue between N is 1 to 10 to the power 3. Another is high cycle fatigue between 10 to the power 3 and beyond that. Now the fact is, why you are talking about Basquin equations, right? As of now, you would have realized to do the life prediction of a structure subject to fatigue cycle, and especially whether constant or variable amplitude loading, you need to refer SN curve. That means for that particular material, you have to have a SN curve available. Later on, you will see not only simple SN curve, you have to have SN curve for different stress ratio, different stress concentration factor. Okay, assuming that you want to do a life prediction of a component of a smooth specimen, there is no stress concentration, and you have to quickly do the prediction roughly to get what is the knowing that some stress value. Even if variable amplitude loading, as an engineering judgment, you can come out what will be equivalent stress amplitude under constant amplitude loading, or you can convert equivalent to that is possible. Or if it is the structure subject to constant amplitude loading, then we need to have SN curve. And please, one more thing you note down, whether you do life prediction under variable amplitude loading or crack growth prediction for variable amplitude loading, always the original basic curve is generated in constant amplitude loading. There is no SN curve made under variable amplitude loading. So now we are talking about only smooth specimen, but you need to do some life prediction. So Basquin came out with very good idea for the ferrous material. You have a original trice slope model. What he did is he joined 10 to the power 6 and 10 to the power 0 one cycle. So this is will give the intercept A, and B is the slope. Slope will be negative because the slope is negative. And this is all narrative, what is low cycle fatigue at cycle. So what he did is, one can generate by joining that for the material, if you know A and B, which is again material constant, material properties of any given material, we will able to do the life prediction even though there is no SN curve available. Okay, forget out if you, unless you have a different stress ratio, that is another additional point, some correction factor required. But assuming that is R, and this Basquin equation is applicable to R is equal to -1, where mean stress is 0. Okay, that I have been telling you, R and mean stress is they are related. R minus is S mean by S max is R, and they are equal and opposite, so mean stress will be 0. So always Basquin equation represent R is equal to -1. Later on, one has to take correction if there is a mean stress, that we will see down the line. And it's always standard practices to use Basquin equation for life prediction because it is a conservative. Your experiment data is coming above the Basquin equation. If you do any life prediction based on equation, still it's a okay, except in this region is there. So that means it's a straight line. Y is equal to mx plus c. If you know m is the slope and c is the intercept for that given material, you can, but how do you get this point and this? Of course, this point we show the true fracture strength. Again, is a material property is available, and this point 10 to the power 6 is the endurance limit for the. We'll talk about what is the situation for the ferrous non-ferrous, which is aluminum alloy. There is no well-defined endurance limit. There, instead of 10 to the power 6, it is always considered as 5 into 10 to the power 8. Okay, so he came out with this relationship. Is a stress amplitude. Please remember y-axis is amplitude here. Okay, whenever you are talking about R is equal to -1, still one can represent mx because they are all interrelated. So you have SA is a nonlinear thing, A and B. A and B is the metal properties, and you can express stress amplitude in the form of number of cycles to failure. If you take log on both sides, you'll have y is equal to mx plus c. There are two unknowns, A and B. We need two equations to find out the A and B. It's a deterministic equations. Two unknowns, two equations. So what is the first equation? At n equal to 1000, of course, he is not talking about 10 to the power 0 one cycle, which is a fruit cell. No? 10 to the power 1000 means n is 10 to the power 3. Okay, that's because we are referring to subsequently all the slides will be discussing only between 10 to the power 3 to 10 to the power beyond 10 to the power 6, because we are talking about stress life approach under stress life. But second unit, which is strain life approach, that time we will be talking about low cycle fatigue. So 10 to the power 3. It is already known as 90% of ultimate strength of the material will constitute this value. Okay, and one thing you please remember, in unlike in other subject where something has to be derived based on some assumption, hypothesis thing, but in fatigue nothing, empirical relation, equations are all based on all test only. Without whatever empirical relation comes, this will come due to the only test results. Subsequently, I will show you all whatever formula has been obtained during, that is obtained based on the testing, nothing on derivation in ab initio. Unlike in defining sigma is equal to m by I, you do some make assumption, right? That neutral axis remain same even if bending, the cross section before bending perpendicular neutral axis remains also same, small deflection, like that you do that. It is nothing like that. You have to do experiment, do some parameter study, come out with the relationship. So 10 to the power 3, it has been known. Why I am telling is that for different material at 10 to the power 3, for ferrous material, it is well established that 90% of ultimate strength will give the 10 to the power 3 that point. And you substitute here, then you simplify that. Then we need another point. So what is 10 to the power 6? That's the endurance limit. N is equal to 10 to 6. The stress amplitude is known as endurance limit for the ferrous material. And also subsequently we will find in ferrous material is 50% of ultimate strength. So you know the 2 points. Even if you don't have SN curve available for the material which is a ferrous in nature, even aluminum also you can do it, because at 10 to the power 3 it is a 75 to 80% of the ultimate is only the first point, and there is no 10 to the power 6. You have to consider 5 into 10 to the power 8 for the aluminum alloy. For ferrous material, it is 50% of the ultimate strength. For the non-ferrous metal, it is around 40% of the ultimate strength. So once you know the metal properties, you construct a SN curve of a smooth structure. So if you solve it, two equation, two unknowns, then finally we will get to know this. The thing is, roughly if you know, if you want to find out number of cycle, or you know, you have to, in the design you have to find out, you have to meet certain number 10 to the power 8 cycle is required to think what should be the stress amplitude. Once you know A and B, you can find that way. Or you want to find out, you know the stress amplitude, what would be the number of cycles required, just but you should know A and B, which is always available. It's a metal properties. It is in the literature, it will be available what is A and B for the different material.